Our final item in this combination of chapters 5 and 6 is to discuss types of chemical reactions. And these are basically just some basic types of chemical reactions. And we'll see many places where these come into play later on in this course. Or if you go on to take any chemistry courses in the future, that's where you'll really start to see these show up. So most of these reactions are fairly self-explanatory from the name. So we first have what's known as an addition reaction. In an addition reaction, two reactants combine to form a single product. And so that might look something like this. Sodium metal, plus chlorine gas. This is always a very interesting reaction when you think about it. But the product here will form 2 sodium chloride. In many ways, a very interesting reaction when you think about what's going on here. You're taking chlorine, something that is a highly poisonous gas. You're adding it to sodium metal, which is a metal that's so reactive you can't let it be exposed to water. If you do let it be exposed to water, it will pretty much instantly react with water and form sodium hydroxide and hydrogen gas. But when you let the two of them react together and combine, you get sodium chloride, something that we eat every day. So the opposite of addition is decomposition. In a decomposition reaction, a compound breaks apart. And so we start with one starting material, and we end up with 2 products. And we can see an example here. Mercury oxide can react and break apart into mercury plus oxygen. Our next 2 reactions are what we would call substitution type reactions. And we have single displacement and double displacement. In a single displacement, we get a single element displaces another. Whereas in a double displacement reaction, at least in the most common examples, the cation and anions swap partners. So in the single displacement, it could be something like this. We have aluminum reacting with iron oxide, and the aluminum is going to switch places. It's going to bump the iron out, and we get aluminum oxide. So you can see the aluminum is where the iron was, and then the iron is by itself. In the double displacement, as we said, we're going to swap partners. So maybe we have sodium phosphate and potassium chloride, and they will switch, and we get sodium chloride and potassium phosphate. Our final two reactions, or two types of reactions that we'll discuss here, are combustion which is a reaction with oxygen gas. And generally these types of reactions will produce either a heat or a flame. And then we get a class of reactions that's especially important biologically. These are known as redox or oxidation reduction. And these are reactions that involve a transfer of electrons. So combustion, we've seen examples of these before, such as any hydrocarbon reacting with oxygen, burning of fuels to form carbon dioxide and water. Redox, these are something we'll get to in our very last chapter, chapter 14. But here we're going to see that electrons actually move. So zinc might react with copper 2+, and the zinc is going to give up 2 electrons. So it becomes zinc 2+ when it was neutral. And it's giving those electrons to the copper. So the copper was positively charged, it becomes neutral. So you can see here, the zinc gave 2 electrons to copper. So those are 6 basic classes of reactions. And that actually brings us to the end of chapters 5 and 6. And our next set of videos, our next set of lectures, will begin with chapter 7, which is where we start talking in much more detail about electrons.